Welcome to Spring LIB.
Hello students, a not so easy problem from ionic equilibrium. We have to calculate the pH of the rainwater where the concentration of the sulfur dioxide that is in equilibrium with the rainwater is given as 0.8 ppm parts per million. KH for sulfur dioxide is 1.0 molar atm and dissociation constant for the acid that is sulfurous acid is H2SO3 is given as 1.7 multiplied by 10 raised to the power minus 2. Under these conditions, we have to calculate what is the pH of the rainwater. Let's start. If the concentration of the sulfur dioxide is given to us, we can calculate easily the value of the partial pressure of sulfur dioxide or the concentration of the sulfur dioxide. In rainwater, concentration of the sulfur dioxide is 0.8 parts per million. Understanding the concept of parts per million, that it is the number of the particles of the sulfur dioxide is 0.8 in 10 raised to the power 6 particles of the water molecule, we can write that partial pressure of sulfur dioxide is equal to 1 atmospheric pressure multiplied by mole fraction of the sulfur dioxide, and instead of that we can write this value, and this will be equal to 8 multiplied by 10 raised to the power minus 7 atmosphere. So this we got the partial pressure of sulfur dioxide. Now we have to remember one equation, and also remember that sulfur dioxide is anhydride of sulfurous acid. It means if we will add water to sulfur dioxide, we will have sulfurous acid, H2SO3. And this equation is going to help us because we can calculate the value of the KH, equate the value of the KH, and the value of the KH, that is the hydrolysis constant for sulfur dioxide, will be based upon this equation, and we can write this as equal to concentration of sulfurous acid divided by concentration of sulfur dioxide. Water is present into huge excess, and multiplied by this will be the apparent hydrolysis constant, and its value is given to us as it has been given 1, and this is equal to concentration of sulfurous acid, thus we want to calculate, divided by concentration of sulfur dioxide, 8 multiplied by 10 raised to the power minus 7, and this gives us the concentration of sulfurous acid in the rainwater, and this is equal to 8 multiplied by 10 raised to the power minus 7 molar. So the concentration is in our hand, and we can proceed further, and let's see the dissociation constant for the acid concept if we can introduce. And introducing the concept, we can write that H2SO3, when it will dissociate, it will give us H plus HSO3 minus, and for this equation we will put the concept of dissociation constant of the acid, and this is equal to concentration of the H plus multiplied by concentration of bisulfite divided by concentration of H2SO3 that remains undissociated in the rainwater. We have to assume that the acid sulfurous acid is very weak. It is not dissociating appreciably further. So, putting the concept that concentration of the hydrogen ion must be equal to concentration of bisulfite anion. And concentration of sulfurous acid we have calculated, and Ka value is given to us. We can put all the values now, and the Ka value is 1.7 multiplied by 10 raised to the power minus 2, and these two components can be written as hydrogen ion concentration to the power 2 divided by H2SO3 concentration. Or we can write hydrogen ion concentration square will be equal to 1.7 multiplied by 10 raised to the power minus 2, further multiplied by concentration of sulfurous acid, and that we have already calculated, and this value was equal to 8 into 10 raised to the power minus 7. So, hydrogen ion concentration will be equal to 1.166 multiplied by 10 raised to the power minus 4. And now there is a term for pH, that is equal to minus log of hydrogen ion concentration, and instead of hydrogen ion concentration we have to write this, and its value is equal to 3.93. So this was the value of the pH of the rainwater under the given conditions. So our final answer is pH of the rainwater is equal to 3.93, and we have to assume that in the acid, mainly sulfurous acid is present in the rainwater, and it is a weak acid. I hope you got the concept. Thank you.